So in this video, let us look at what orthocentre is and let us look at the properties of orthocentre. So first, what is orthocentre? Orthocentre is the point of concurrency of altitudes of a triangle. The point of concurrency of altitude of a triangle is called the orthocentre. That is, for example, if you have a triangle A, B, C. So first draw the altitude from the vertex A onto the opposite side. Altitude means the line which is perpendicular to BC. So from A, draw a height or altitude onto BC. Next, from B, draw an altitude onto AC. And from C, draw an altitude onto AB. So all of them will meet at a point called the orthocentre. It is usually denoted by the letter H. So orthocentre is usually denoted by the letter H. So now, what are the properties of orthocentre which you need to understand? So the first property is about the location of orthocentre. Location of orthocentre. So for an acute angle triangle, the orthocentre lies inside the triangle. So for an acute triangle, orthocentre lies inside the triangle. Now if you take a right angle triangle, so let us take a right angle triangle A, B, C. Let us take that this angle A is 90 degrees. Now what is the orthocentre of this right angle triangle? So to find the orthocentre, we need to draw the altitudes. So from C, if you draw the altitude, obviously altitude means a line perpendicular to AB. So this AC itself will be the altitude. The CA is perpendicular to AB. So this is one altitude. So what is the altitude from B? So the altitude from B is a line which is passing through B and perpendicular to AC, which is BA itself. So this is the next altitude. This is one altitude, this is the next altitude, and the third altitude is nothing but the line through A perpendicular to BC. So this is the third altitude. So where are all of these meeting? They are meeting at the point A. That is, for a right triangle, the orthocentre is the right vertex itself. The right vertex is the orthocentre. It's a very important property. Whenever questions on orthocentre is given, you need to check whether the question given contains a right angle triangle or not. If it contains a right angle triangle, you don't need to do anything. The right vertex will be the orthocentre of the triangle. And if you have an obtuse triangle, let us say that A, B, C. So let us say that angle A is obtuse. So how do the orthocentre look like? So if you draw the altitude from A, it will be like this. So if you extend it, this is the altitude. Now, how does the altitude from B look like? So you cannot draw altitude like this because this angle is obtuse angle. So if you want to draw a perpendicular, it lies somewhere like this, right? The perpendicular looks like this. So these two tend to meet somewhere here. So if you draw the altitude from C onto AB, you need to extend AB and draw the altitude. So they are meeting outside the triangle. So for an obtuse angle, orthocentre lies outside the triangle towards the obtuse angled vertex. We have seen that for obtuse angle triangle, the circumcenter also lies outside the triangle, but towards the hypotenuse side. The circumcenter lies on this side of the hypotenuse. The orthocentre lies on the side of the obtuse vertex. So I hope you understood the first point about the location of orthocentre. So let us go to the next point. For example, let us take the triangle ABC and H be the orthocenter of triangle ABC. H be the orthocenter of triangle ABC. So if H is the orthocenter of the triangle, now what we are going to say is, what is the orthocenter of triangle BHC? So what is the orthocenter of the triangle BHC? It is the triangle formed by two vertices of the original triangle and the orthocenter. So what is the orthocenter of this triangle? So how do you get the orthocenter? You need to draw the altitudes of this triangle. So from H, if you draw the altitude, that is same as AH. And what is the altitude from B onto HC? That's nothing but from B you need to draw a perpendicular onto HC. So obviously you cannot draw it inside. So you have to extend this outside, and this angle is 90 degrees. And BA is the next altitude. HA is one altitude. And what is the altitude from C onto BH? So you need to extend BH. Because this angle is 90, this angle is also equal to 90. So CA is the third altitude. And where are they meeting each other? They are meeting at the point A. So the orthocenter of triangle BHC is nothing but the point A. That is the remaining vertex. What is the orthocenter of triangle BHA? Orthocenter of triangle BHA is nothing but the vertex C, right? If you have BHA, the orthocenter is nothing but the vertex C. So what is the orthocenter of triangle ACH? ACH. This is nothing but the point B. So this is a very frequent question which will be asked from the concept of orthocenter. So if H is the orthocenters of the triangle formed with the orthocenter and two vertices will be the remaining vertex. I hope you understood the second point. So now let us move on to the third point. So the third point that you need to remember is that the image of orthocenter with respect to any of the side of the triangle always lies on the circumcircle of the triangle. The image of orthocenter with respect to any side of triangle always lie on the circumcircle of the triangle. That means if you take the orthocenter, the image of orthocenter with respect to BC lies on the circumcircle somewhere, and the image of H with respect to AC, so if you take the image of H with respect to AC, that will also lie on the circumcircle of the triangle. And if I take the image of H about AB, so that will also lie on the circumcircle of the triangle. So this is the theorem. So how is this happening? So let us try to prove this theorem. So to prove this theorem, what I need to show is, so if this point is some S, so if I just show that HS will be equal to SP, then H will be the image of P, because it's already perpendicular, the line is already perpendicular. For the image, just this length has to be same as this length. So let us try to show that HS is equal to SP. So to show that, let us take a construction. Let us join BP. Let us join BP and let us take these two triangles. Let us take these two triangles. So in these two triangles, triangle BHS and triangle BSP, are there any things which are same in these two triangles? So this angle is 90, this angle is 90, both are 90s. And this side is common in both of this side is common. Next, are there any other things which are same in both these figures? So can I say that this angle is same as this angle? So let us see whether these two are same. So first, if you take this triangle B, so let us take this as T. So in triangle BTC, one angle is 90 degrees, the other angle is C. So this angle will be 90 minus C, right? 90. So these two combinedly has to be 90. So if this is C, this is 90 minus C. So angle HBC is nothing but 90 minus C. So is this angle also equal to 90 minus C? Let us see. So angle PBS is same as angle PBC. Angle PBS is same as angle PBC. Now angle PBC is the angle subtended by the chord PC on the segment of the circle. So PC also subtends this angle. This PC also subtends angle PAC on the circumference of the circle. So angle PBC has to be equal to angle PAC. Now what is this angle equal to? So what is this angle equal to? Let us take triangle. In triangle ASC, angle S is equal to 90 degrees. One angle is C. The other angle has to be equal to 90 minus C. So angle angle SAC. SAC is equal to 90 minus C. So if SAC is equal to 90 minus C, angle PBC also equal to 90 minus C. So this is 90 minus C, this is 90 minus C. Hence, two angles are equal and the included side is same for these two triangles. Hence, these two triangles are congruent to each other. Triangle BSP is congruent to triangle BSH. So these two triangles are congruent, hence the corresponding sides are equal. HS is equal to SP. Hence, the image of H about BC is nothing but P, which lies on the circumcircle of the triangle. Similarly, you can prove the other conditions also. So you can prove that H image about AB will be R and H image about AC will be equal to Q. So this is a very important property. The image of the orthocenter about any side of a triangle always lie on the circumcircle of the triangle. Let us try to calculate the distances of the vertices and the sides from orthocenter. So let ABC be the triangle and H be the orthocenter, which is the intersection of the three altitudes. For convenience, let us draw only two altitudes. So H is the orthocenter that you have. So what I am trying to calculate is the distance of H from the vertex A and the distance of H from the side BC. So I am trying to calculate AH and HD. AH and HD. So how do I do this? So first to calculate AH. So now let us try to see some angular properties in this figure. So in triangle ADC, this angle is 90 degrees. One angle is C. So what will this angle be? This angle will be 90 minus C. Is okay. Now in triangle AHE, this is also a right angle triangle. So if you want to go to AH, so let us take cos of 90 minus C is equal to cos theta is equal to adjacent side by hypotenuse AE by AH, right? Now what is AE? So AE can be found out from the triangle BEA. In triangle BEA, right? In triangle BEA is a right angle triangle. Angle E is equal to 90 degrees. Now if you take this total angle A, what is cos A? Cos A is equal to adjacent side AE divided by hypotenuse is nothing but the total side C. This implies AE is equal to C cos A. AE is equal to C times cos A. That's the cos component of this. We have seen this in projection rule also. So AE is equal to C cos A. We just need to put this here. So what is cos 90 minus C? Sin C is equal to C cos A divided by AH. And this implies AH is equal to C cos A by sin C. That is equal to, so what is C by sin C? C by sin C. From sine rule, A by sin A is equal to B by sin B is equal to C by sin C is equal to 2R. There is nothing but 2R cos A. So the length, the distance between the vertex and the orthocenter is nothing but 2R times cos A. So if you want the distance from vertex A, you need to put 2R cos A. Similarly, if you want the vertex, the distance from the orthocenter to vertex B, you need to do 2R cos B and 2R cos C. So once you have AH, so you can similarly derive BH is equal to 2R cos B and CH is equal to 2R cos C. Next, once you know the distance from the orthocenter to the vertices, can you find this distance? Can you find this distance? HD. So this is also quite simple, because what is BD? BD is nothing but C cos B. From the projection rule, BD is nothing but C cos B, because this angle is B. So C, the cos component is C cos B. Now once you know this, can you find this? What is this angle? This angle can be found out from this triangle. So in this triangle, one angle is 90, one angle is C. So this will be 90 minus C. So now which ratio will I use? Tan 90 minus C. Tan of 90 minus C is equal to HD by C cos B. HD by C cos B. This implies HD is equal to C cos B times tan 90 minus C is cot C. Cos C by sin C. And what is C by sin C? C by sin C is again 2R. So 2R cos B cos C. So HD is equal to 2R cos B cos C. 2R cos B cos C. What is AH? AH is 2R cos A. So if you want the distance from the vertex A, you need to write 2R cos A. If you want the distance from the side BC, the answer is 2R cos B cos C. So if you want the distance of this from side AC, you need to do 2R cos A cos C. So my HE will be equal to 2R cos A cos C. And what is H? F, if you want the distance here. So HF will be equal to 2R cos A cos B. So these are the distances of the orthocenter from the vertices and the sides. So these are the properties which you need to know about orthocenter. Thank you.